Okay, so let's suppose that we wanted to rewrite with only constants and cosine of 2 thetas the expression sine squared theta cosine squared theta.
Sine squared theta equals 1 minus cosine squared theta.
Okay, so sine squared of theta is 1 minus, oh, why am I doing that? Okay, so we want to notice that sine squared of theta is 1 minus cosine squared of theta, right? Staggering identity. So then I get 1 minus cosine squared theta times cosine squared theta. Okay, cool. So then I distribute maybe and get cosine squared theta minus cosine
I mean, to the fourth.
quadruple, yeah, cosine to the fourth of theta. Okay, now, is this a good idea? Got some bad shit going on. Yeah, which of these is the mad shit that's going?
Cosine to the fourth.
Yeah, I don't know how to deal with cosine to the fourth, right? You guys all see that?
This could be a bit of a roundabout way, but you could think of cosine 4 as, cosine squared times cosine squared.
That's probably better.
Yeah.
So we've got cosine squared times cosine squared.
And then you rewrite all that as, you got 1 plus cosine 2 theta over 2 minus cosine.
Good. So use the half angle identities on each of these, right? Oops. Was it calling those the half angle or the double angles? Half angles.
I don't know why.
You let theta be theta over 2. So I'll show you in a second. So if you use the half angle identities, cosine squared of theta is 1 plus cosine of 2 theta. Oops. 1 plus cosine of 2 theta over 2, right? So I got one of those, and then there's minus that thing times itself.
Or you could just put that thing all squared
Perfect.
instead of rewriting it twice, 3 times, I guess.
Okay. Cool. This. Check. This is in terms of constants, right? Like I've got a 1/2 here, right? And cosine of 2 thetas. Great. You could FOIL this out. It'd take a while, but whatever. The other thing you could have done is up here at the beginning here, right? You could have done the half angle identity for cosine on this and the half angle identity for sine on that. Cool.
Oh, yeah. Isn't it for sine? Isn't it 1 minus?
Oh, yeah.
Yeah.
Cosine 2
For,
theta?
so if you did that at the beginning, right?
Sine is the minus cosine.
You'd have 1 minus cosine of 2 theta over 2 times 1 plus cosine of 2 theta over 2. And conveniently the top there is difference of squares, right? So you could notice that this is 1 minus cosine squared 2 theta all over 4.
Would you prefer that to be the answer, or could we have just stopped at the?
I don't care.
Okay.
It depends on what you're trying to do with it. If you're trying to do calculus to it, you probably want to go to here.
Okay.
And actually, if you're trying to do calculus to it, you probably want to go to the next one anyway, where you dump this in favor of cosine of 4 thetas. You guys recognize that? You could use the half angle again, right? So if you use the half angle again, you get 1 minus, and then in there should go the half angle formula for cosine, right? Which is 1 plus cosine of twice something all over 2. What goes in here for this something? What goes in there?
2 theta.
Yeah, there should be a 2 theta in there, right? So all told, you get cosine of 4 theta in there. Cool. And then a little simplification, a lot of algebra will get you to a reasonable thing. Cool. Questions, issues on this one?
But can you
Wait. What was the thing that I said I was going to say at the
Half
end?
angle formula?
Oh, yeah, the reason we call this a half angle formula. So this thing really set, like the cosine squared version of this, right? Says that cosine squared is 1 plus cosine of 2 theta all over 2, right? Okay, so the reason you call it a half angle identity is you can rewrite this just letting theta equal, I don't know, call it phi over 2, right? And then this is cosine squared of phi over 2, right? Is 1 plus cosine of what?
Phi.
Just a phi, right? All over 2.
Yeah.
So sometimes they're written this way and then they're obviously the half angle formulas. You could take a square root of both sides, right, to get a confusing answer. Cool.
Thank you.